This is my first big project until now. It's graphical user interface for manipulation with three-dimensional data. It's oriented on widgets and all the functionality around manipulation with three-dimensional data. You could add items from my menu by clicking on them to my menu. My menu is special widget, which also replaces classic context menu. You have better access to frequently used items. Also, here we have toolbar. By right clicking on toolbar items, you could add them to another special menu. It's called My Collection. This is a circular menu. Actually, toolbar is multi-layered and could be expanded, and by right clicking on any item, you could add it to My Collection, and all icons are properly scaled. Here is a sidebar which serves for views. It's called view bar. You could store their views. You could anytime return to any view. You could remove any view. Sidebar. This sidebar view bar could be also hidden to extend workspace. There are two small widgets for orientation. Also, new approach is used for a moving model and for choice of orientation axis. You could choose orientation axis by moving mouse cursor over side of the cube. You could move model, you could rotate it, you could scale it. Also, new metaphor is used for placing cutting plane. It's placement of plane on a ball. By using this approach, you could access any position. You can access any position for cutting plane, and here it is. This is all basic functionality of graphical user interface, and now here we have extension to three-dimensional space. You could see our workspace in the bottom of box. This is box level. In box level there could be placed three-dimensional icons. They are placed on sides of this box. They could be scaled. We could choose here items from database. We could write here comments. Also, when you have multiple windows opened, there is simple window management. From this level we could move to higher level, workspace level, and here you could have opened multiple instances of this graphical user interface, this program. So when we move down, we open another file. We move up, and everything what we changed in this instance is saved. Here we have application which I have developed for computer vision using OpenCV. Basically, it's controlling mouse, its movement, and events by colored glow. As you can see, areas are colored areas are properly detected, and mouse is moved. Every shaking and similar artifacts are removed. There are two gestures for left mouse click and right mouse click. Every event is processed, so event for mouse up and mouse down is processed separately. Now let me show you collection of algorithms I have developed for task of color tracking. Basic task is to have as much as you can accurate and robust color tracking algorithm. First of all, some pre-processing. Here is background subtraction, so it makes your algorithms a little bit faster. Another is basic approach, is basic idea of my approach. It's image histogramization. Using this approach, you can decide what items are in which cell. Here is motion detection. Basically, you could detect flow in image. This is also part of approach I have used. I have used this for following. It's for not for this one, but it will follows. This one is detection of one item. It's pink colored glow. As you can see, detection is pretty fast and pretty accurate, also when glow is away. And here we go. This is point tracking algorithm, basic on Lucas candle algorithm. It's based on optical flow in image. And here we have automatically placed points. They are placed on edges. And here is our result. I have used colored glow with checked pattern, which is pretty accurate and robust, especially robust against some disturbance in environment. So any pink or green object wouldn't mind if we want to detect our glow. Its accuracy is 2 meters away from camera. Now let me show you a collection of programs on polynomial surfaces and procedural modeling. Here you could see Bezier tangent surface. It's represented by points, but it's smooth by clicking here. You could view tangent lines and a normal vector of any point on surface. Here we have cyclic construction. This construction is rational, so you need less points to represent this surface. This construction is used, for example, if you want to connect some object to plane. For example, it's used for trees. Here we have triangular construction, triangular Bezier polynomial surface. Also, we could view normal of any point. All of those previous constructions are used for procedural modeling. In our case, it's procedural modeling of grass. We could add blades of grass on this surface and it looks pretty realistic, and it's also pretty fast. They could also grow. Simple 3D editor. You could add objects, you could move objects, scale, rotate, you could paint objects and change projection. Simple 2D editor, everything is pied by pixel, for example. And here is also cutting. Simple racing and in Flash, you could select your car, you could select your car, track and number of laps, and here we go, you are racing on time. Simple Bomberman game, you could create your own environments and you could play the game. Adventure game, in which you could pick objects, you could combine objects, you could move between environments, and there is also editor included, in which you could create your own environments and actually a whole new game. Simple find picture game, you can play with computer or with multiple players. Diffie-Hellman key exchange scheme, you initiate communication and then you send your message and everything is encrypted by curves. Collection of small Java games as duck shooting, Sudoku, Sokoban, or Hanoi Towers.